So today we are going to see one easy level coding interview question called this unsorted squared array. So what we do here is, first thing, we have an array. So when you just need to square it, and when you square it you should get the array also in ascending order. So for example, we have 1 2 3 4, and here the output should be 1, and then 2 into 2, which is 4, 3 into 3 is 9, 4 into 4 is 16. So this is the output. So the same thing over here. So -3, -2, -1, 0, 1 2 3 is the input. Now here's the trick. So you can't like just directly multiply them. I mean, you can't just directly give the number like this, because if you directly write the number like this, it won't be in ascending order. So it should be in -3. If you do it directly, you will get something like -9. I mean, you will get something like 9 over here, and then 4 over here, 1 over here, which is not arranged in ascending order. So it has to be arranged in ascending order. So this is the tricky part. So anyways, this, if you give this as the input, this should be the output. So let's begin. So one brute step approach is, first we can sort this input array. Okay, after sorting we will the new array we can take and just multiply all its values. So that is fairly simple. So first sort, and then just square whatever element, just loop over this array and square whatever element you get. So that's one way to do it. So that will take nlogn time, because for sorting it takes n. Okay, nlogn time and n space. So this is an okay method, but let's look at a more efficient method. So the more efficient method is where we have a time complexity of only n, not n log n, nothing, just n, and the space complexity also as n, since we are returning an n array output. So both time and space complexity is n. So let's look at that method. So the method is like, since the input will always be in sorted order, sorry, I forgot to mention that, since the input is always in sorted order, so we can take two pointers. So we can take two pointers. So this one is one pointer and this one is one pointer, and then what we have to do is take this, compare the absolute values and 1 and 4. I'll tell you why we have to do the absolute. So anyway, so we take the absolute values of 1 and 4. So here the absolute value of 1 is 1, absolute value of 4 is 4. Okay, if left pointer is greater than the right pointer, so here left pointer is not greater than the right pointer. So what we have to do is, if this left pointer is not greater, it means the right pointer is greater. So let me write it like this, it will be much easier to understand. So 4 is greater than 1, so right pointer is greater than the left pointer. So in this case, what we have to do is, okay, so in our case now this 4 is greater than 1, so we move the so first thing is we create a new array. So this is the, let me keep this one as the result array over here. So since 4 is greater than 1, we square the larger number. Okay, so in our case it is the right pointer. We square the larger number and add it to the end of the result array. So now that we have added over here, initially the pointer will be pointing to the end of the last result array, So after we add it over here, we move the result pointer over here. So next, after we do the 4 is greater than 1 comparison, since 4 is greater than 1, this number is already done, so we move the right pointer to the left, decrease it by 1. So next again we compare, is 3 greater than 1? Is 3 greater than 1? No. So again we do the same thing. So we add the right pointer into right pointer over here, which is 9. So we add it to 9. We add it to this place because the pointer is pointing to this one. And then what we do is we decrease the right pointer because the right pointer is greater. We decrease it like this. Now again we compare these both. 2 is greater than 1. Is 2 greater than 1? Yes, it is. So 2 is greater than 1. So in that case we again do the same thing. So sorry guys, I forgot to move that point over here. So we move the pointer, we move the pointer over here. So then we do the comparison. 2 is greater than 1. Yes, it is. So we just add the 4 over here. Okay, we add the 4 over here, and then we move the move this result array pointer by 1. Next we move this one also over here. Now right pointer and left pointer is both pointing to the same element. So now we just do 1 into 1, which is 1. We add it over here. So this is the logic. So now for clarity, let's look at this one, the second example. So let me just erase all of them. So this is the array. Okay, now so now what we do over here is, again we have the left pointer, then again we have the right pointer. So now we have, so do the same thing. So compare the absolute values. In this case it is 3 is greater than 3. So if 3 is greater than 3, it is false, right? So we can move any of the pointers to the right or the right pointer to the left. So it's up to you. So let's move the right pointer to the left. wait, so 3 is greater than 3, right? So the first thing is we add that 9 to the array. Okay, next array make the result array point to the next one. So and then we move the right array by 1. So after that we again compare the same thing. So now we have 3 is greater than 2. So 3 is greater than 2 is true, right? So left pointer is greater than the right pointer. So now that left pointer is greater, we move the left pointer. Wait, so now 3 is greater than 2, right? So just take this 3, okay, and add it to the array, add the square of that to the array, and then move it over here. Move the result array pointer to the next one. So now 3 is greater than 2, so take this left array and make it point over here. Okay, so next we have -2 and 2. So now we compare 2 is greater than 2. So like I said, you can do anything now since both the elements are the same. So I'll just move the right pointer over here. Okay, before moving that, again we just need to add the element over here, which is 4. Okay, so next, after adding it over here, move the result index array over to the next one, to the next array pointer. So next, after this, you can move any of the pointer, left pointer to right or the right pointer to the left. So now it is -2 is greater now, so now it is 2 and 1. So 2 is greater than 1. So in this case, now add the square the greater value and add it over here. Okay, so after adding it over here, move this one over here. So after doing that, so move, since this is the greater number, move the element, move this one over here. So now again we have 1 is greater than 1, so just add the element over here like 1. So after that we move the element, any one of them, move the pointer to here, left or right, anything, you can move that also here. Okay, so now we do 1 is greater than 0. Yes, 1 is greater than 0. So we move, so 1 is greater than 0. Yes, so we add 1 over here, right? So after we add 1 over here, we move the element over here. So now both of them are pointing to this one. So 0, so since both of them, so again 0 is, so just add the 0th element over here. So now we got, so now again when the while, so now again right pointer will go over here and the left pointer will go over here. So left pointer, we should go on iterating until left pointer is lesser than or equal to. So as soon as it is greater, we can come out of this array and we will have the result array like this. Okay, so now let's see the steps. Let's write down the steps. How to move this? Okay. Okay, looks good. Okay, so first step, so the first step is create a result array. Why it is going to the right? Create a result array. Okay, make the result pointer point to the end of the array, that is input array -1. So what we did, we are making it point to the end. So next so the second step, create two pointers, lp left pointer and rp pointing to the start and the end of the input array respectively. Third step is if abs of right pointer is greater than abs of left pointer, so do rp add rp star rp to the result array decrement decrement result pointer rp minus minus. After that let me call this result index. So result index minus minus. Okay, and result array minus minus. Okay, so after doing that, just decrement the right pointer. Create two pointer. So else whatever we do, add left pointer, just do the opposite, star left pointer to the result array lp plus plus, do array minus minus before that, lp plus plus. So after that yeah, that's it. Step 4. So let's do these steps. int array is equal to new int array, that length is array dot so the next one is create two pointers, left pointer and right pointer. So int array is equal to result array dot Okay, next if create two pointers, int left pointer is equal to 0, int right pointer is also equal to array dot length minus 1. So next if math dot abs of array of right pointer is greater than math.abs of array of left pointer add a right pointer and right. So start next array minus next rp minus okay, next else p is an mp test plus while left pointer is greater than or equal to right pointer. Left pointer is less than or equal to right pointer. So then you will return array, return result array. So let's see if this works. Okay. Okay, reached the end of the file. I think I should add more. Okay guys, it has passed all the test cases. Okay, so now this one was the second method. So This one has a time complexity of n, since we are just iterating each through each of the element. So n n time un and n space, since we are returning an integer array. So let's look at the second solution. This is the easy straightforward solution. So let me just comment this. So just sort the array first. So I'll do call arrays.sort array. So now the elements will be in it. Already elements will be in sorted form when it is input. So first I have to just square each of the element. So just square each of for I and ti is equal to 0, I less than array dot I plus plus. After that, so let's declare a result array. Array dot next. Square each of them. So result of 0 result of I is equal to array of I star array of I. So this, that's it. So now array so return arrays dot sort result. That's it. What is the issue? Oh, not find simple. Okay, it's returning a void, this one. So just return array sult. So here you go guys, this one takes nlogn. We can ignore this one taking, it's actually nlogn plus n, but we can ignore the n since it's a very less element compared to nlogn. So we'll take nlogn space, nlogn time and n space, so the first solution is more efficient. So that's all guys, thank you for watching.